I'm going to show you different ways to define finite elements. Please note that for the purpose of this video, whenever we say finite elements, we are referring to membranes, plates, and shells. For this example, we're interested in the shell elements. So let's proceed to the first way we can achieve this. It is through panels. If we go to the panel element window, panel element tool rather, I'm gonna build a shell mix mesh. For this example, I'm not gonna worry about thickness or changing the mesh properties, since I'm not gonna run an analysis. So I will define 3 by 5 panel, and you can see it here. And with these properties I have defined, I'm gonna click here, mesh panel elements of type membrane, plate, or shell, and I'm gonna accept this. It has created a 4 by 6 shell elements. All of them are quadrilateral, so if we go to the quadrilateral element tool, we can see that all of them are type shell. Now let's see the second way you can obtain a similar group of shells. We're going to define a shell element right here by clicking on these locations. And please be aware the orientation of your shell. This was my first node, so this is joint I, J, K, and L. I will need to divide this to get a similar shell configuration. If I select only this element, I need to unselect all and then select only this shell element. I go to subdivide selected elements, and for quadrilateral elements from I to J, I'm gonna subdivide it by 4, and J to K, I'm gonna subdivide by 6, and I click OK. As you can see, I have the same configuration. Similar goes for the triangular elements. Let's do a quick demonstration. If I define my point I, J, and K, I will unselect all, and with the selection tool I will select only this triangular element and do a similar process, but this time I'm going to focus on triangular elements. From I to J, this will divide the number of links you want. In this case I'm going to set 2, and for the J to K, which is from here to there, I'm going to select 3 links, and I click OK. As you can see, from I to J we have 2 links, and from J to K we have 3. Before I forget, there's another way to define 2D finite elements. If we go to quadrilateral element tools, and you can specify the number of links from I to J, let's say 6 links, and from J to K we can specify 4 links, and you just need to define your shell. So from I to J I have 6 links, and from J to K 4 links. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.